good morning, everyone. Welcome to this session. My name is Bonolo Mathibela from Spacetime Consulting. And today we're very fortunate to have with us lead developers from both the PX4 and ROS projects. And we'll be talking about how these projects have worked together in the past and what the future looks like in terms of collaborations. So if the panelists could please introduce themselves, starting with Daniel. 2 or 3 sentences about who you are and how you got started with robots or drones.
I'm Daniel Agar. I'm the de facto maintainer of PX4, I guess, and I've been working on this since 2014.
Hi, I'm TJ Stastny. I'm fixed wing guy, aerospace for quite a while, and working on PX4 during PhD, and then postdoc, and now at Auterion on the flight control team.
I'm Tully Foote, open source lead at Intrinsic. I've been working on ROS since before ROS existed, circa 2008 in Willow Garage. Very happy to be excited about drones, but also general robotics.
Hi, I'm Geoff Biggs. I'm currently the CTO of the Open Source Robotics Foundation, which is the steward of ROS and a whole lot of other open source robotics projects. I've been doing open source for robotics since about 2003, and I remember 2008 was when Brian emailed me saying, hey, we got this new project called ROS, it's pretty cool. So yeah, been around for a while.
Thank you. So let's dive right in. What is it that makes PX4 embedded software development hard?
Is that you?
Is that me? Yeah, I can take it. Yeah, so, I mean, let's see. I think recently, something I've also noticed back in research days and now also working with, companies and customers, there is like a happy path that we have on PX4, like plan a mission, things are normally going to work out the right way. I think what we need to do a bit better at is, as soon as you want to put your customization inside, so let's say I want fancy path planner on the outside doing whatever fancy path planner wants to do, we got to improve the interfaces a bit to make it easy to put these things into the standard workflow. And that's at least one struggle I had back in research again, and now I think we're actually making some good progress on working towards getting those interfaces put in place with PX4. Expanding to ROS, that'll be more discussion, I guess.
And what is the value of using simulations like Gazebo for drone development? And are there any limitations to simulation-based development?
The value, I think, we've known the value of simulation in all kinds of robotics for a long time, and that is that when you break your robot in the simulator, it doesn't cost you anything. Whereas, I think everyone here who's tried drones or any kind of flying robot, or if it crashes, it tends to cost a lot because you have to repair it, and that's long been a problem in robotics and in drones, I think. So that is really the biggest value. Another one is repeatability. You can do it rapidly. You can just quickly go through a bunch of simulations. Don't have to keep charging batteries or anything like that. There are limitations, of course. It's a simulation. It's not necessarily 100% accurate to the real world. Certain things like the way the wind behaves or change in inversion layers and things like that may not be present in your simulation, which means at some point you're going to go out and test in the real world.
And do you have any strategies for how to overcome some of these limitations?
Well, we continuously improve the physics simulation. I think Gazebo, I don't know if we've got much of an effort on aerial robotics, but recently we've been doing a lot for marine robotics where you're trying to improve the fluid simulation and the way the robot behaves under the water and ballast and things like that. But I think it'll be interesting to do a lot of that for aerial robotics as well, for drones. See if we can add in more realistic atmospheric effects on their impact on the drone's flight and things like that.
And so, historically speaking, what are the ways in which PX4 has integrated with both ROS1, ROS2? Maybe, Tully, you could take that one.
Yeah, it's been really exciting to be coming back here every year to the PX4 Dev Summit. I remember we got ROS started, and it was really, really exciting when the first, there's usually a PhD student would pick it up and put it on a drone. And it was often literally just like glued on top sort of thing. We had some early integrations, if you remember, like the Parrot drones way back when, people using the APIs to integrate ROS and running ROS off-board. Then it moved to like an embedded computer that was basically glued on top. And over the years, we've gone from, it's a PhD student who does something really cool, demonstrates it, and is basically no integration with the Autopilot or the onboard systems, to now we're actually, it's really awesome to see here where there are integrated ROS capabilities that are running on board the drone, providing that higher level functionality. I've been here and trying to help this community understand what are the resources from general robotics that can be brought into the ecosystem. And it's been really, really great to see little pieces being picked up, where there's lots of great capabilities out there. It's open source in general robotics, and now it's here. We've been able to bring in the simulation. We've been able to bring in these higher level planners, the perception capabilities. All of those can come in. Observing the world is not specific to drones, so it's been great to see all of that just happening over the last decade.
And what would you say is the current status of PX4 ROS integration, and where do you see this going? What is the end point?
Let's see. So the idea of interfacing PX4 and ROS2 is obviously not new, but what's new now in stable PX4 is that I think we finally got it right. We've been slowly evolving PX4 to be more directly in line with ROS2, like same messages, everything. And it's now part of default PX4, so going forward it's going to be like a core part of quite a lot of what we do.
Great, thank you very much. I think we have time for some questions from the audience. There's 2 mics. If we can take our first question, please.
Hello. So what you see with PX4 and ROS bridging is more like a compromise, like we try to bring in the PX4 messages inside of ROS and try to bridge that. Is there an idea to have more inline communication, so we can have command file integration inside PX4 parameters? Or I've played around with it. Problem is kind of it's too big for PX4 maybe because the message size, or is there like a common ground?
So I think that there's 2 major components to this. We have 2 big communities, and we need to move carefully, because if we try to move fast and break things, everyone's going to be unhappy and go home, and it's just not going to work. There are definitely constraints coming from both sides. If you look at the ROS ecosystem, like we're designed to be very generic. And part of being generic is you get a little bit bigger, you get a little bit more flexible, and as you mentioned, the sizes can be a problem. And so we need to work to find ways to bring the size down, to potentially to make it better for the smaller embedded computing. We're really, really lucky also that embedded computing is like getting faster. What we're doing now would not have been possible with the hardware we had 5 years ago. And I think that as we're looking forward, I'm working hard to make people understand that the most important thing is actually the semantic information in the message. If we can agree on the semantic information in the message, there is the possibility to do automatic conversion between representations. So it can be in full like ground robot, we're using 64-bit with large padding and like fully generic messages self-describing, and then maybe as long as we agree on the semantic information, we can export it down and say, like, okay, for this application, we use a very stripped down thing that doesn't have all these fancy features, but we still make sure to get that same data through. And then that's just an engineering effort that somebody can write, auto-generate code to do the translations. So I really want to encourage people. There's a great effort, the community working group, trying to bring standardize the messages for drones, and I think that's one of the most important things. And from there, once we have that standardized messaging, we can work on how do we make sure it's accessible for all the hardware.
And is this happening within the aerial robotics working group?
Yeah, there's an aerial robotics working group in ROS that I hope that some of them are here. I haven't seen them in person, but I encourage you all to come out and participate in that process.
Okay, great. Next question, please.
Yes, thanks. My question is actually kind of maybe a more generic version of that, which is like, what are the kinds of things that the ROS project can do to help PX4 and help the integration, right? I mean, there's obviously stuff that has to come from both sides, but I'm just curious, you know, what the ROS project can do.
I think that on the ROS side, when we started ROS 2, one of our goals was to make it able to be really stripped down to low resource usage for smaller systems. And I think enabling a variable level of resource usage based on which part of the system you're in would be very helpful for that. Another thing is communications methods that are better suited to the drone use case. You know, we can't really use DDS, which is great if you've got a wired network, but can tend to cause problems in wireless situations or situations where you've got a lot of computing nodes involved, as you know. So I think making it easier to talk between a ROS 2 system and a drone, even without being on board the drone, would really be a big advantage, I think, because then you can enable applications like, for example, a ROS 2 base station controlling a fleet of drones, for example, or integrate a fleet of drones into a wider fleet of ROS-based robots. Things like that would really bring in some really interesting use cases, I think.
Thank you.
Please go ahead.
Yes, my voice is coming. Okay. I like the echo here in the middle. Maybe this question is like more on PX4 side. So considering the fact that like the changes that we are ever already implemented and the connection between PX4 and ROS 2 that we have now, I was wondering what if there's any like future being seen like where PX4 is going to be like, or like what are the goals like, what we could be expecting more like from PX4, and if there's any like more timeline on that, and how closer it's going to be to ROS in the future. So it is basically like more on PX4 side. So where we are planning to go more afterwards, or if there's any plan at all yet.
So internally, PX4 has always been, at least the way I thought of it, is kind of like an embedded-friendly mini-ROS. We have a pub subsystem, parameters, little nodes, but again, focused on more embedded flight controller. What I'd like to see going forward is that instead of being our own little mini-ROS, we evolve to be more of a flight stack on ROS. If that makes sense.
All right, thank you.
Could you expand a bit on that when you say a flight stack on ROS?
We want to focus on flying drones, not reinventing middleware and solving these problems in our own little way.
Okay, yeah. Please go ahead.
Hello. So I think from we're talking kind of technical here, and I know there's some business people in the room. For projects, what do you think this means for like projects if you're describing this to a business person? How does this affect their developers? How does this affect their ability to execute on their visions? How does this affect the amount of people that can work on their projects, having PX4 and ROS more tightly integrated?
I think there's two aspects of this. First, in the ROS community, we actually have more than a few commercial ventures, startup companies, for example, who are already using ROS and drones together for interesting applications. For example, one of the most interesting I've seen is a drone that at regular intervals will scan every box on a shelf in a warehouse to try and reduce loss of things. Things apparently just get lost in transit all the time in logistics. It's like more than 10% loss rate apparently, which is insane. And so that's somewhere that would benefit from tighter integration, better integration, because they would be able to have their developers work together better rather than like the drone team and the ROS team or something like that, right? And that also brings in the other aspect, which is that you get a much wider talent pool that you can hire from, which means you can hire better engineers more easily. I mean, we all know that engineers are becoming increasingly scarce around the world, especially the ones that have the skills you need. And so if you don't have to have such a siloed capabilities of your engineers, it becomes a much more flexible team composition. You can hire better talent more easily, and it just makes it easier for you to build better systems faster, I think.
Thank you.
What's going on? So the question before this one, you might have answered it, but I still want to ask it anyways. Right now, PX4 needs a companion computer to do advanced things, computer vision, and so on and so forth. Will PX4 ever get to a point where the Autopilot itself, or the software and the hardware, you'll be able to do this without a companion computer, all these advanced things all in one?
I've never really liked the term companion computer. I don't know, maybe this is just my perspective, but it's all the flight controller, right?
Yeah.
There's real-time embedded piece, more compute to decide, but it's all your flight controller, so.
Okay.
So I think the other one is, we need, for flying, we need the real-time safety. We need the, keep the drone in the air. It needs to stay safe. Mm-hmm. Historically, that component has not had the ability to have the higher level computation, the more CPU horsepower. Looking forward, we're getting more and more devices now where there are systems with integrated real-time capable microcontrollers and onboard microprocessors that are potentially on the same die, or at least in the same circuit layout. I think that this is mostly a history of where we're coming from, and that we have these separate systems, and we're bridging them. Over time, we've seen that bridge is getting tighter and tighter. We're getting much higher bandwidth. It used to be your microcontroller had a serial port, and you counted the bauds in hundreds of kilos. Now we go up to megabit connections between the microcontroller and the external system. So we're getting more and more integration, and that's going to keep going. So that line between what is companion computer, what is flight controller, will be getting smaller. But I think it's important also to maintain that there is a sort of core kernel which makes sure things stay safe. Mm-hmm. And that needs to be certifiable and keep everything safe, and everything else can run separately.
But for the overall goal, those lines, you guys are working to make those overall lines smaller and smaller. Is that what I'm getting?
Yeah, definitely. I mean, it's not one extreme or the other. It depends on requirements for what you're actually doing in a project. Sometimes there's certain real-time things. Sometimes that's not as much of a factor.
Okay. Thank you.
Hi, I'm just curious where the panel sees Mavros fitting into the collaboration between the two, as I don't think you've touched on that yet.
I guess I'm interested in, again, the much tighter integration between ROS and PX4. There's kind of a separate thing to the side, the need for more standardized messages that you can count on. Mavlink for basic telemetry, command and control. So I think there's still maybe the need for that, but for kind of the core flying robot, what's running on the vehicle, PX4 directly talking to ROS2 over PubSub is the thing I'm personally pursuing.
I think the Mavlink and Mavros, they're really valuable when you're going through the very limited bandwidth connections. And what we're looking at the tighter integration because we have the higher bandwidth connections available. If you have those very, very limited connections like those low frequency radio links, we need that. Again, this is getting to that stripped down messaging. I think one of the ones that would be great is if we can evolve and connect this, again, what I was talking about earlier, the semantic information, make sure that what we're talking about in the high bandwidth links can also go over those low bandwidth links with a very, very specialized messages.
Thank you.
We have time for one more short question. Please go ahead.
It's me at the other microphone. So I wanted to know, what are some features in ROS that PX4 developers need to know about? Maybe we don't know about or don't talk about enough.
I mean, it's really everything. We want the whole toolbox. Stop reinventing things for ourselves, right?
I mean, for example, like, I mean, exactly this, like ROS has tons and tons of robotic tools that people have been using for rovers, also aerial robots, robotic arms. So like there's lots of perception pipelines, open source ones, planners, let's say like OpenPL, something like this, like that have ROS wrappers. And so it's just really nice if you can have access directly to this and then just command the drone and not need to re-implement any kind of parsing, any kind of own implementation, or try to somehow distill this into a microcontroller format, for example. So I think what Daniel was saying earlier as well about, actually, so the phrase he's been using, which I like a lot, is that the microcontroller is not like the autopilot, the whole system is the autopilot. So companion versus microcontroller, we should delete that line except for real-time requirements. And planner can communicate directly then with the controller. And now ROS has all of this infrastructure, all of these different things people have worked on over the years that we can start adapting to aerial robotic use cases.
I think there's something from the slides a couple days ago at ROSCon. There's something like 1,300 open source packages out there. I don't even know all of them. And I would encourage all of you to go out and like think about what do you want to do with a drone, and then look for ROS packages that implement it. Because yeah, there's a plethora of planning, perception, control, etc. There's a lot out there. It's been the aggregate work of thousands of people. So
Even just plotting. We used to have our own special tools, and now some of us live in Plot Juggler. So.
That's all we have time for today. Thank you very much to our panelists, and of course you can find all of us outside if you have any more questions.